Hi everyone, this is Jacob and it's finally Friday. Today I wanted to go over all the different types of contention and interference that we experience in our networks. I would like to start off by just posing a question. How much contention and interference do you believe is on your wireless network? Hopefully through this finally Friday, you will have a better idea of what we're talking about when we talk about contention and interference and see that it's much more important than you might first think. So one reason why that's a little bit of a trick question that I asked is because the wireless network itself is based off of contention. Contention is what allows a wireless network to work. Without contention, our wireless networks would just stop working. This is because only one device can talk at a time when we are dealing with a wireless network. So when this iPad is talking, then it is the only device that can talk on the network. This is called contention, where these devices are competing for airtime. There is a whole long process that they go through where they will wait and make sure the channel is clear, because if the channel is not clear and they go ahead and transmit, then they will cause collisions, which causes retries and other errors, which ultimately will cause problems to your wireless network. We know that a device will transmit not only in the direction of the AP or device, but in all directions. We know that devices transmit omnidirectionally, so that means not only is this device transmitting to the AP, it is also transmitting in all other directions as well. That means any device that hears this one cannot talk during that time. Whenever this device is done talking, then the next device can talk. And they take turn this way where they don't step over each other. This is called airtime utilization. Whenever there's energy in the air stopping another device from talking, the airtime is being utilized. That is key to all wireless networks. Whenever your airtime is completely used, then no matter what kind of signal you have, or how many more APs you add to your network, you cannot move any more data. Once that device is done talking, the next device can talk. And this obviously happens very rapidly throughout our networks, but that is how wireless works. This is good contention. This is the kind that we have to deal with, because if this were to stop, wireless would break. But there are other types of contention and interference that we do want to avoid, and some are easier to avoid than others. The first type that I wanted to talk about is adjacent channel interference. This is one of the worst types of interference. However, it is also an easier type of interference to address. Adjacent channel interference happens in two different ways. In 2.4, it would happen if you're not using the standard 1, 6, and 11 channel plan. And that is based in the United States. In the United States, we only have channels 1 through 11. So the only 3 non-overlapping channels within those 11 channels are 1, 6, and 11. If we were to use channel 5, like we have in this diagram on the left, if the AP on channel 5 talks, then anything that hears it on channels 1 through 6 has to stop talking, because it acts like it's on all 6 of those channels. We will see that in a little more detail a little later on. On 5 gig radios, we'd see adjacent channel interference when we are dealing with dual 5 gig APs. If you have 2 radios on 5 gig in the same AP, and the channels are very close together, like 36 and 40, then you can experience some adjacent channel interference because the radios are so close together. That's why it is industry best practice to separate those 2 radios by at least 80 megahertz. This is Ekahau. This is the program we use to show where to put APs in a building. And what I've done here is place APs across this school building. You can see the legend in the top right, where gray is more than 5 APs on the same channel. So anywhere you would stand within the gray, you would hear more than 5 APs on the same channel. green is 1 AP on the same channel, and the darker red it gets, the worse it is getting. Ultimately, we want to try to keep that down to only 3 APs on the same channel in 2.4. And ideally, in 5 gig, we would keep it down to no APs heard on the same channel. That is hard to do, but it's not completely impossible, especially if you're using all of the 5 gig channels. What I want to show here is if I change the 1 AP in the center of the map that is half covered by the box to channel 8, you can see that the co and adjacent channel interference gets much worse. Gray covers a lot more of the area, and in fact, it reads like there's 9 APs in the same channel right there at that AP on channel 8. So that just demonstrates how important it is to run channels 1, 6, and 11 on the 2.4 spectrum. It is critical. I'd actually challenge you to go into your wireless controller and make sure that you're only running channels 1, 6, and 11 in your 2.4 environment. If you're not, make sure you change that. It will for sure improve your network by making just that one change. The second type of interference that we deal with is co-channel interference. And this is one that you'll probably hear more about. There are 2 types of co-channel interference. There client AP co-channel interference, which is more prevalent than the second type that we will get into in just a second. In client AP co-channel interference, the client on one AP can hear another AP on the same channel. So what that looks like would be in this scenario, on the left, the AP is talking to the phone, and on the right, an AP is talking to the iPad. But we know that when this signal goes out, it goes out in an omnidirectional pattern. So the phone can also hear the AP on the right. When this is the case and they transmit at the same time, we get a collision. And the collision will cause that transmission to the cell phone to fail. Any kind of transmissions like voice or video that have latency sensitivities, this can cause issues for. We can avoid this by separating these 2 cells out further where the devices cannot hear another AP. The second type of co-channel interference, which is even worse, and we still see it often, is when 2 APs can hear each other. This is even worse than the first type because not only does the transmissions affect the clients of the AP, the transmissions also affect the APs. So if the iPad on the right transmit at the same time the AP on the left transmit, and the APs can hear each other, then now the AP itself is having errors, and it's having collisions and retransmissions, which turns these 2 cells into acting like they're one AP. Anytime the AP on the left talks, the AP on the right can either talk or listen to devices on its network. These issues cause these APs to turn into one large cell with shared capacity instead of 2 individual cells where we can drive up our capacity. We want to avoid this at all costs. This last type of interference is one you may have never heard of before, and that's because we do not have a program that will test for this. However, we know it exists because of the nature of RF. Client-induced interference is when a client on one basic service set is affecting a client on another. What I mean by that is these cells are completely separated, therefore they're not sharing capacity like we saw in the last slide. However, the clients on the edge of the cell has stronger signal strength than the AP on the edge of the cell. Therefore, the cell phone on one AP can be heard by the iPad on another AP. This also causes interference whenever the cell phone transmits. We know once again it will transmit in an omnidirectional pattern, and it will also affect the iPad. Therefore, the iPad cannot transmit or receive during that time. If the AP on the right were to transmit at the same time the phone transmits, we get a collision at the iPad, and it does not receive that transmission causing those retransmissions and the latency that we want to avoid. This is by far the hardest type of interference to deal with. It is almost impossible to eliminate this out of your network simply because we have no test for it and it extends your cells out much further. And the reason this happens is the nature of RF loss. RF in free space will lose around 40 dB in the first meter. Therefore, a client that is further than a meter away from the AP will always have a higher signal strength than the AP will, simply because of the loss in signal strength. I can show you an example of that by once again getting on Ekahau. I put a client on the edge of an AP cell to show the difference in the range. If you look at the top picture, you will see that we're reaching out to basically the 45-yard line on a football field. This is an American football field. And if I put that AP right there on the 45-yard line, actually a little closer, and that guarantees that it's going to have usable signal from the AP, you can see that we are reaching out to the 30-yard line. Therefore, we're gaining 25 yards of usable signal strength past the AP's signal strength. You can visually see here that the cell has increased in size tremendously. And this would be dynamic. As the clients move around in the environment, the cell size and shape is going to change. So why do we care about co-channel interference and all these interferences? Ultimately, it comes down to poor end user experience. Whenever network airtime utilization gets to around 50%, then you're going to see some of your data be affected, especially in high latency sensitive traffic. That is your voice and your video. That traffic will definitely be affected at 50% airtime utilization. When you get up to 70 and 80% airtime utilization, then your data is going to be affected. Your network is going to start slowing down at that point. Ultimately, all these interferences, co-channel interference, adjacent channel interference, and client-induced interference is going to reduce your system capacity. We're buying APs in order to make sure everybody who needs on our network can get on. And whenever we start having these interferences, we are eliminating some of that capacity. In the diagram on the right, all those APs that are on the same channel are going to have the capacity of one AP. So that is something critical to keep in mind as we move forward. And that is what we're going to be fighting against. This is by far the biggest issue when it comes to your wireless network is the airtime utilization. Ultimately, when you run out of airtime, there can be no more transmissions on your network. That's it for this Finally Friday. I appreciate you joining me. Hopefully you've learned something. Reach out to me if you have any questions. Wireless is something I really enjoy working with. And I will catch you next week when we talk about channel design and how we can use channel design to eliminate some of this interference. Have a great Friday.